Alright, this is the coding teacher and I'm here to teach you how to code. I'm kicking off this new series about algorithmic tests. I'm going to start with a really easy one. This is a problem that's kind of like the foundation, the basics of MergeSort. And this is the problem statement right here. I'm using REPL.it, which is the thing I just discovered is freaking amazing. So anyway, all you gotta do is write a function which, given two sorted arrays of length greater than 1, will return one sorted array greater than or equal to 1. Actually, I gotta change that. Will return one sorted array containing all the elements in both arrays. So again, this is the heavy lifting behind MergeSort. What does this mean? Essentially, let's say that you have two arrays, right? This is 1, 2, and 9, and this other one is 3, 4, 5, 11. Okay, so what you want to come up is you want to merge these two into a fully sorted array, and obviously, the left one's length is 3, the other one's length is 4, so the final one is going to be length 7. So, and the contents should be 1, 2, 3, 4, 5, 9, 11, right? It's a very easy problem. They're short arrays, so we can eyeball that. But how do we approach algorithmically the solution? Basically, we need to create a pointer to the first element that we're at here and another one here. So we're going to call this left one left hand side and the blue one right hand side. Okay, and basically what we're going to do is compare call this one array 1, and this one is array 2. So now we're comparing array 1, the element located at LHS, index LHS in array 1, we're comparing that to the element located at RHS in array 2. So basically we're seeing if ARR1 at LHS, if that's less than or equal to ARR2 at RHS. If that's the case, then we're gonna grab this element and stick it here, in the first slot right here. And now we're gonna move LHS to point there. Now we're gonna do the same comparison again, right? Is ARR1 at LHS less than or equal to? So is this one less than or equal to this one? Yes. So we're gonna go and stick this 2 right here, and LHS is gonna move here. So now we're gonna do the comparison again. Is this one less than or equal to this one? No. So now what are we gonna do? We're gonna move we're gonna stick, this guy's gonna come here, 3, and we're gonna move our HS over there. Now we're gonna do the comparison again. Is the one at LHS less than or equal to the one at RHS? No. So we're gonna grab that 4 and stick it right here, and RHS is gonna move here. We're gonna do the comparison again. Is this one greater than this one? No. So we're gonna grab the 5 and stick it right here, and we're gonna move RHS to this one. So now, is this one less than or equal to this one? Yes. So finally, we're gonna put that 9 right here, and then we put the 11 right here. So that's pretty much the gist of the algorithm. And now what does that look like in code? Well, first of all, we gotta create a result array, right? Alright. I always, tend to forget retarding the thing that I'm building, so I like to write it in the beginning. Now we're gonna create those pointers. Let left hand side equal 0 and right hand side 0. Okay, and now how long are we gonna keep trying to make this stuff happen? How long are we gonna keep this make this work? So one way to approach this would be while LHS plus RHS is less than AR1.length plus AR2.length, right? Because if that's the case, that means that either LHS or RHS or both haven't reached the end. So we gotta keep running. And now what do we do inside this loop? If, basically this thing that we have right here, if LHS, but there's one important caveat, if LHS already reached the end, then we can just insert LHS, right? So what are we going to be checking in this if? We're going to be checking all the possible circumstances where RHS is the one that we need to insert into the array. So if LHS is greater than or equal to AR1.length, that means that there's no more viable LHSs and I need to insert RHS, right? Or AR1 at LHS is greater than or equal to AR2 at RHS. And again, what I'm trying to cover here is all the cases where what I need to be inserting into the array is RHS. So what do? Result that push AR2 RHS plus plus. And now note that there's a little bit different, what I wrote here is slightly different from what I wrote here, because I ended up going like in this array, you end up assuming that whenever you find something that's equal, you insert from the left. In this solution, whenever you find two elements that are equal, you insert from the right first. Doesn't really make a difference. In the end, the result should be the same. Now, else, one more thing. Right here, when I evaluate AR2 at brackets RHS, what's really happening is this. And then, after that's being pushed into the array, then at the very end of the statement, RHS gets incremented. So that's why you can do it in one shot like that. Else, result.push AR1 LHS plus plus. Alright, so let's run some tests. And there it is. There might be a little thing that I missed there, but usually, if you're quick and snappy and they give you a problem like this and you solve it in 2 minutes, and you missed, one tiny little edge case, the interviewer will kind of throw you a bone and tell you, hey, look, what about this case? That's what's happened to me in lots of cases, and it doesn't really hold you back that much from getting the job. I think what holds you back is if you're fumbling around for a long time, or if they give you a problem as easy as this one and you don't get it within 5 minutes, that's definitely going to hold you back. So that's it for today. This was the Coding Teacher. I hope that was helpful. I'll see you guys next time.